So this video is going to walk us through how to create an assembly in OnShape of the servo claw that we're seeing in the video. The idea behind creating the assembly is to create a proof of concept to make sure everything fits well together in 3D modeling before we take the files over to the 3D printers in the Innovation Center and actually print everything out. So this is the final assembly of the build that we saw at the beginning of the video. And as you can see, we can move everything and everything responds. The claws respond to each other. When I move the right claw, the left claw responds in time. There's limits, so I can't move it too far, so I can only move it back this far. I can only move it up this far. But now we're going to go through the process of actually putting everything together to get this final assembly. So the first thing we want to do is go ahead and create a new document in OnShape so we can do all of our assemblies and we can pull in our files and everything that we need to do to build the assembly. So I'll go ahead and create a new document. I'll just name it Servo Claw Assembly V1 because I already have a regular Servo Claw assembly where I built the assembly for this video. So now we have a blank document. I'm going to go over to the Insert tab. I go to Import, so I can download or I can import the files that I downloaded for the assembly. If you were doing something like building an assembly from something on Canvas, you would download the files from Canvas and import them in the same way I'm about to do right now. So go to Import, make sure I go to my downloads. That's where my downloads are or where my files are. So I have 3 files I'm going to import. I'm just going to highlight them all, hit Open, and then Import Appearances. And then hit import. Just leave everything the same. I don't mess with this. Just hit import and OnShape will start pulling everything in. We'll see down at the bottom, it'll start populating. Now this is done. I'm going to hit X on that, close that menu. I see down at the bottom I've got quite a few tabs. Anywhere you see this cube, that is an assembly. Anywhere you see the 2 different sized solids, that would be a part file. The assemblies are the ones we're interested in. So the assembly here, this is one of the claws with the attachment for the servo. This is another one of the claws with a attachment for a bearing. All these files is just the individual parts of those assemblies. So for this video, we don't care about these part files, but these part files are what the assemblies were made from. But in this case, we just downloaded the assemblies and brought them in. So we're going to just go ahead and use the assemblies. To make everything easier, I'm going to just drag my assemblies to the left side so I don't get mixed up. This assembly 1 is nothing yet, but that's where we're going to do all of our building. And then I also want the servo claw bracket, which is kind of the holder for everything. So I'm going to drag this over as well. Everything else over here I don't need for the video. So we have the right claw, the left claw, a blank assembly, and then the servo claw bracket. So first I'm going to go into the assembly 1, which is the blank assembly. I'm going to go up to Insert, and I'm going to pull in a model of our servo that we use in first year. So I'm going to go Insert. I'm going to go to go to Other Documents, go to Home. I'm going to search, type in FYE Servo, hit Enter. It's going to bring up a lot. Because as a first year student, a lot of our builds or modeling on OnShape become available to all the students. So all these builds are all the student builds, but this FYE SG90 is what we want. So I'm gonna click on that. So click on the top one there, bring it in. I can put it wherever I want. Does not matter in this case. I'm just gonna click it, and now it's brought in. I'm done importing for the minute, so I'm gonna hit the check mark. And then we brought in a lot with this file. We don't want all this. We have the horns that go on to the top of the servo. We don't care about those for this video. So I'm going to click on them. You can see it gets highlighted inside the servo. So right there's a screw. There's one of the horns. There's another horn. I'm going to click on that and I'm just going to click delete. I don't need it for this video. Again, with that horn, delete it. That horn, delete it. That horn, delete it. So now I have the label. Again, I'm going to get rid of the screw as well. So delete that screw. So we have the label. We have the mount on top of the servo and then the servo body. Before we move on, there's one more thing we need to do with this. If I click on this and drag it, you'll see that not everything moves together. So I'm going to hit Control Z to get it back where it was. I'm going to highlight it by just clicking and dragging. I'm going to come up here to the top bar and click on Group. And you'll see that it includes the three things, the label, the tower, and then the body. I'm going to hit the check mark. And now when I move it, it all moves as one piece. It might move a little bit laggy. That's just OnShape responding to it moving all those parts. So now the servo is brought in, it's grouped together so it moves as one piece. So now we can start bringing in the rest of the pieces for the assembly. So I'm going to go up here to Insert. I'm going to go back to my current document. Right now I'm on the other document. I'm going to go to the current document. And I'm going to bring in the servo claw bracket. There were some instances where I was working with this video and the servo claw bracket did not show up until I had the composite part button clicked here. So if you're working with this and for some reason you don't see the servo claw bracket available, there may be a button up here that says composite parts. Click on that and then you should see the servo claw. But I'm going to click on the servo claw, bring it in. For now, I'm just going to hit the check mark. So what we're going to do with this is we're going to make it so it does not move. Because right now I can move it around freely, which is fine. But when you're doing an assembly, you kind of want one of your pieces to be fixed and not move. So we're going to click on it. We're going to highlight it, right click on it, hit fix. And now if I try and drag it, it will not move. So this piece is fixed now. Our next step is to mount or mate the servo into this slot right here. One thing to note about this bracket that I have designed is there's a slot, there's a channel in the back which allows the wires from the servo to flow through it. On our servos, the wires come out of this side, on the left side, on the side closer to the horn. So I'm going to click on the servo and get this origin to appear. I'm going to click on this circle with lines to do a rotation. I'm going to rotate it 180 degrees. And again, the only reason I did that was to simulate where the wires come out of our servo on this side, so that way the wires align with this channel when we actually print everything out. So now we're going to do some mates. So we're going to come up here and click on planar mate. We're going to click on, in this case, we're going to start on the left side of the servo. This distance from here to here is the same as the height of this bracket. So I'm just going to click and have the circle of the mate appear right in the middle so you can see how the mate circle moves around. I want it to mate in the middle of the servo side here. So I'm going to make sure that circle appears on the left side or in the center of the side. I'm going to click. Sometimes it takes a minute to react, apparently. So when you see it actually say mate connector there, that means the mate connector has been registered. I had to click a few times. I think my OnShape is just moving a little slowly. I'm going to use my right button of the mouse to rotate and then come over to the bracket here. I'm going to click in the middle of that side as well. I'm going to hit the check mark. So it looks good. But if we drag it, we can see that the servo still moves. All that means is this side and this side are mated. So we can see that if we move it, it does not move beyond that side. I can't move it any closer to me. It'll just kind of slide along that plane. So we're going to do a couple more mates to get it to be actually fixed. So we're going to do another mate. We're going to click on the bottom of the servo this time, so get that yellow circle to align on the bottom. Be careful to make sure that it is on the same plane as the side of the servo. So we're going to click. Again, it appeared over here, so it sees the mate. We're going to rotate again, come into our bracket, and click where that circle is on the inside plane. Hit that check mark. We're close to done. The servo can still move up and down. It can't move any other direction, but it can still move up and down. So we're going to do one more mate. Do a planar mate. I'm going to click on this ledge of the servo. And then click right here as well. Hit that check mark. and now the servo does not move. If I click and drag on it, that servo is now fixed to the bracket. So now we can go ahead and start bringing in the two sides of the claws. So we're going to go back to Insert. We're going to make sure we're in Assemblies. We don't want to bring in the part files because that would bring in the individual parts of the claw. So we want to bring in the claws that have everything assembled. So we're going to bring in the left claw with bearing first. All that means is it's the 3D model of the claw with a model of the bearing included. So we'll bring it in. Just put it over here off to the side. Hit the check. We're going to highlight it again, just like we did with the servo. And we're going to group it. And that way, when we move it, everything moves together because there is that bearing model in there. So now we're going to do some mates that are called revolute mates. All that means is that it is a mate that allows rotation about an axis. So we're going to go up here to the top. We're going to click on the revolute mate. We're going to zoom in on our claw. We're going to try and make sure we get our mate identification in the middle of the inside circle. So you can see I'm kind of moving my mouse around right now. This is the bottom of the bearing. If I move my mouse inside, you can see that the mate identifier moves inside as well to the inside of the claw. So we're going to click there. Make sure that it appears over here. Then we're going to come back up. The bearing will go on this post right here. So we're going to zoom in on that. We're going to click right there at the top of the post. And then we can see that it aligns and it fits on very snugly like it's supposed to. So we're going to hit the check. And then we're going to just manually rotate. We're going to close this first. We're going to manually rotate this. So again, click on it to get the origin and the rotation axis to appear. So we're going to start with this rotation here. And we're going to do I'm going to do 101 degrees solely because that is how this claw was designed. This claw is somewhat offset from this claw in terms of the teeth of the gear. So usually if you were doing an assembly of your own build, you'd have to go through and rotate everything incrementally until you got it where you want it. But in this case, I know how far to rotate it. So we're going to do a 101 degree rotation. And then we'll go ahead and bring in the right claw. Again, make sure we're in Assemblies, not Part Studios. Bring in the right claw with the servo mount. Bring it over here to the side. Hit the check. We're going to highlight the arm again, or the claw again. We're going to do group. Hit the check. And we're going to do another revolute mate. And then we'll come in here. We'll click inside the servo mount. Again, I'm not clicking up here. I'm clicking on this face, on the inside face of the mount. And I'll come over and make sure it sees the mate connector. We'll come over to the servo and we'll click on the very top of it. So right now what I did was I flipped the axis, so we can see that the way I had it was sitting too far down onto the servo. All that means is that the claw is upside down, so we're going to flip the axis, and that way we see that the claw now aligns with the left claw, and we can see that it's sitting on the servo mount more correctly. So now that we did that, we'll hit the check. We'll close out of this because we're not doing any more revolute mates, and then we'll go ahead and rotate this claw as well. So we'll click on it, get the rotation axis. We'll start with this one or remove this one. We'll do a 90-degree rotation. And again, these rotations are not arbitrary. It's just where I built this, I know what degrees to rotate the claws. If you're building this yourself or if you're building your own design, you will likely have to go through and figure out those rotation degrees as they pertain to whatever you're building. So now we have everything built, but if I move this claw, the left claw does not respond to it. I'm going to do Control Z again just to put it back where it was. So now we're going to do a gear relation. So when this gear moves, this one responds. So we're going to click on the gear relation. We're going to click on, it wants to know what mates to use to relate it. So for that, we're going to use the revolute mates. So we're going to come over here to the left side. We're going to click on the revolute 1 and then revolute 2. And when we have this relation ratio here, that is the gear sizing ratio. In this case, these gears are both the exact same size, so there's a 1-to-1. If this gear on the left was twice the size of this gear, we would make that relation ratio a 2-to-1. So the ratio over here is just pertaining to the size of the gears or the number of teeth on one gear to the other gear. In this case, the gears are the exact same size, so we're going to leave the relation ratio as 1. We'll hit the check mark, and now we can see that when I move the right gear or the right claw, the left one responds in kind. The issue that we see though is that the teeth are just on top of each other, which is not how a gear works. Again, that's happening because these gears are exactly the same. So I'm going to hit Control Z again just to put everything back. What we're going to do is we're going to rotate this claw by 11 degrees just so the teeth line up. Again, I know that because I'm the one who designed it. If you were going through and designing it in your own assembly, you would have to go through trial and error and figure it out. That's exactly how I did it. I just moved it X amount of degrees until I got it where I wanted it. So we'll come over here to revolute 1. We'll click this arrow. We'll look at where we had the mate connectors. We're going to double click on the top mate connector. We're going to do move, rotate about Z. We'll do 11 degrees. And then hit check. And now we can see that the teeth align like they should. And now when I move the claws, everything moves like a gear would in real life. The only problem now is that I can move these claws beyond the point where they move in real life. Because a servo can only go so far, and also once those teeth start hitting the solid areas of the claw, it would bind up. So one more time, I'm going to hit Control Z to put everything back where it was. We're going to come over here to the revolute. We're going to double click on it. We're going to go to limits. So we see that right now it's saying it's at a 0 degrees. So right now where this left claw is sitting is it's at 0 degrees. So if we wanted to go to where it was originally, we'd have to go 90 degrees, 180 degrees, 270 degrees. So we'll say our maximum is going to be 270. Again, that's because this is 0 and we're assuming that the right rotation is positive. So 0, 90, 180, 270 to get it to be back where it was. The minimum, we're going to say 170 degrees, and then we'll hit the check. And now when I move the claws back, it will not go beyond the tips of each other. So if I try and move them to the left, it will not go any farther. But if I move back, we'll see that it'll stop. Actually, we have a little bit of an issue there with that tooth, so we're going to go back and we're going to change the revolute limit. We're going to say more like 150 degrees. That one made it worse, so we're going to make it higher then. This is exactly what I was saying, just trial and error, just see what works. So we'll try 200 degrees in this case. Hit the check. That looks better. So now it won't go beyond that. So now it'll go up. I cannot move it beyond this, which is what would happen in real life. The servo claw would come together, it would not go beyond itself, and then we can bring it back, and then it'll stop right about there. I can't go any further. And that is somewhat representative of the range of the servo. So now we have a fully completed servo claw assembly with both claws, the servo and the bracket all mounted to each other, all mated to each other. The claws respond to each other when you move them, and they have a limited range of motion. So it's very, very similar to what you would see in real life. So this is a very good proof of concept, and we see that everything meshes pretty well together. So I would be confident to go ahead and start printing this on the 3D printers in the Innovation Center.